Welcome to Maths and Science by IITian channel. In this channel, we will be discussing about the sets, lecture number 2, in which we will be solving a Diophantine equation. The number theory Diophantine equation is clubbed with the sets, and it's a very good example clubbing the algebra of sets with the Diophantine equation. It will be useful for IIT JEE, and also Maths Olympiad. Here, in this example, Diophantine equation is nothing but an equation where a quadratic equation or a polynomial equation or a linear equation in which the coefficients a, b, c are integers, except that we need not worry about the process of solving the equations. Hence, whenever a Diophantine language is used, word is used, we have to see that the coefficients of a, b, c are integers, polynomial coefficients or linear equation coefficients. It can be ax plus b, then a and b are integers. Here ax square plus bx plus c is equal to 0. That means we have to ensure that a, b, c should be integers. Then only single equation is given in set form, and we have to solve for a plus b plus c is equal to how much? Where the root of the equation is a prime number. It's a quadratic equation. A set P is such that P is equal to x is such that ax square plus bx plus c is equal to 0, and we have to find the value of a plus b plus c is equal to how much? If the root of the equation is a prime number, that is x is equal to a prime number. That is what is our condition. Whereas one single equation, 3 unknowns, that is the solution is also integer solution, then that is a Diophantine equation. And the equation is written in the form of set, and P is equal to x is such that ax square plus bx plus c is equal to 0, and x is a prime. This is the definition of the set. We can even find out the cardinality of the set. Cardinality of the set. If any more equation like if a plus b plus c is less than 10, if something like this is given, we can find the cardinality. Cardinality is nothing but number of elements in the set P. So that set theory is coupled with number theory, and it's a combined question of set theory, set algebra, and also number theory, and we have to find out the ABC values such that ax square plus bx plus c is equal to 0 forms a Diophantine quadratic Diophantine equation. That is the meaning of this question. It's a very good question. Pay attention to it. We will solve it now. Let us first try to interpret the question. What is the question given? Question is equal to set P is equal to, the elements of set P is equal to x is such that ax square plus bx plus c is equal to 0. That means the roots of the equation, quadratic equation, are the values of x, and x is equal to prime. This is the set of the elements x. The definition of x. Now, we have to find out so that this definition is satisfied. And we also try to find out the cardinality of the set. T of set P. That implies NP. If A plus B plus C is less than 10. Let us try to do it. We can have two questions in it and we can solve. The first question is ax square plus bx plus c is equal to 0 to have prime roots as prime numbers. Here, if you see, for a quadratic equation, if P and Q are roots for this quadratic equation, then what is the condition given? P and Q are prime numbers. Then the sum of the roots, prime numbers as roots, is equal to minus b by a. That is from the basics of the quadratic equation, sum of the roots. What is the product of the roots? Product of the roots is equal to PQ, that is equal to C by A for the product of the roots. When ax square plus for ax square plus bx plus c is equal to 0. Here, let us say for a is equal to b is equal to c, it is very easy to find out. Let us not go for it. Let us say a is not equal to b is not equal to c. Another condition we impose on ourselves for better understanding of the problem. What are the equations we have got? P plus Q is equal to minus B by A and PQ is equal to C by A and A is not equal to B is not equal to C. We have to find out A plus B plus C. How to find out? What is A plus B plus C? A plus B plus C is equal to In P and Q terms, B A we will write as it is, plus B is nothing but minus A into P plus Q, minus A into P plus Q. C is equal to A into PQ. That implies A plus B plus C is equal to A minus AP minus AQ plus APQ. Can we take A as common here? PQ minus P minus Q. That can be written as A into A plus B plus C is equal to A into here A into PQ minus P minus Q plus 1, because 1 is also there, this is also there. A into P minus 1 into Q minus 1. Do you agree? PQ minus P minus Q plus 1. That implies in A into P minus 1 into Q minus 1. This is another equation, another identity we have deduced from the given conditions. Here, roots we have given as prime. Here P and Q are prime. That is the condition given in the set. Now, what are the prime numbers? 2, 3, 5, 7, 11, 13 and so on. Let us try with a value, minimum value of P is equal to 1, P is equal to 2. And roots were never told that they cannot be equal. It was only we have assumed that ABC are equal. ABC are not equal to each other, they are distinct. P is equal to Q, Q is equal to Q, it implies A plus B plus C is equal to A into P minus 1 is 1, Q minus 1 is 1, that is equal to A. That means B plus C is equal to 0. And another thing what we have? P plus Q is equal to minus B by A. P plus Q is equal to minus B by A. That implies A, B, C we wanted a distinct value. P is 2, Q is 2. 4 is equal to minus B by A. And PQ is equal to C by A. That implies B is equal to minus 4A. What is the value of P into Q? That is also 4. 4A is equal to C. C is equal to 4A. B is equal to minus 4A. From this, A is equal to 1 implies A is equal to 1, B is equal to minus 4 and C is equal to plus 4. Which implies A is not equal to B is not equal to C, that condition is fulfilled, and P is equal to 2, Q is equal to 2, both are prime roots. Then what is the A plus B plus C value? A plus B plus C is equal to 1 minus 4 plus 4, that is equal to 1. A plus B plus C is equal to 1. Let us say A is equal to 2. This is for this P is equal to 2 and Q is equal to 2. Now let us say A is equal to 2. And also here we have taken A is equal to 1. Now P is equal to 2, Q is equal to 2 and A is equal to 2. What happens? B is equal to minus 8, C is equal to 8. That implies A plus B plus C is equal to 2 minus 8 plus 8, that is equal to 2. If A is equal to 3 in the same condition, that implies B is equal to minus 4A minus 12, C is equal to plus 12, that implies A plus B plus C is equal to 3. Now, is there any value under the same condition if A is equal to 4? That means these conditions will go on. These values will go on infinitely as long as this A plus B plus C is equal to A into P minus 1 into Q minus 1 is satisfied, and if P and Q are primes, it implies a plus b plus c is equal to a into p minus 1 into q minus 1. It goes up to infinity. Infinity number of solutions are available, but if I put a restriction that if a plus b plus c is less than 10, I don't want these infinite solutions for a plus b plus c. If it is less than 10, that condition if I put, what happens is that we can derive a limited number of triplets, limited number of triplets can be formed such that a plus b plus c is equal to a into p minus 1 into q minus 1, where pq are prime. P and q are prime. This is the condition given. We have seen if P is equal to 2, Q is equal to, what are the possible things we can have? If P is equal to 2 and Q is equal to 3, we will have some more values for ABC. If P is equal to 2 and Q is equal to 5, we will have different, like that we will have number of possible PQ values such that PQ are prime, that is 2, 2, 2, 3, 2, 5, 2, 7, 3, 3, we can go this way, 3, 5 and go on. But ultimately the value of a plus b plus c cannot be such that a plus b plus c is less than 10. That means a into p minus 1 into q minus 1 is less than 10, because we have got the condition from above. Problem is that a plus b plus c is equal to a into p minus 1 into q minus 1. And a, b, c are distinct. We can take any pair and cross check. For example, P, I have taken it as P is equal to some 10, let us say. Q is equal to some 10. What happens? a into 10 minus 1 into 10 minus 1 is less than 10. That implies a into 9 into 9 is less than 10. Not possible. That means there is a restriction for the value of P and Q. There is a restriction for the value of P and Q. Because we wanted a plus b plus c to be less than 10. That means a into p minus q into p minus 1 into q minus 1 should be less than 10. And p and q are the prime numbers. That means positive integers, prime numbers. The roots of the equation p and q are primes. Positive primes, positive integers rather. Primes means integers. Integers, those who do not have any factor other than the number itself and 1. And a also we wanted it to be an integer because it is a Diophantine equation. Are you able to understand everything? Under these conditions, there are limited number of a plus b plus c values depending upon whether a plus b plus c is less than 10 or less than 100 or less than 1000. Here two conditions are important. One is Diophantine equation implies a, b, c to be integers. Please keep this in mind. This is one condition. And second condition is P and Q are prime numbers. This is the condition given. That implies PQ to be positive integers, compulsory. Positive integer primes. Hence, when you put a condition a plus b plus c is less than 10 implies a into p minus 1 into q minus 1 is less than 10. P and Q are greater than 1 and positive integers and prime numbers. Where a is being a Diophantine equation, it is an integer. Hence, the restriction of P and Q and A, the restriction of A are going to play a vital role, and the combinations of for example, we can take P is equal to 2 and Q is equal to 2. That implies A into 1 is equal to less than 10. This is possible. A is less than 10. Possible. Yes. P is equal to 2. Q is equal to 3. That means A into 1 into 2 less than 10. That means A is less than 5. That is P and Q have to be, another condition, P and Q have to be prime numbers. 2 is prime, 3 is prime. For example, P is equal to 3. What happens? q is equal to 3, that implies a into 2 into 2 is less than 10, implies a is less than 2.5. That means what are the possible values of a? Possible values of a are 1 and 2. That means if a is equal to 1 and p is equal to 3 and q is equal to 3, we have a solution. If p is equal to 5, let us say, next prime, and q is equal to 5, that is also prime, let us say, a into 4 into 4 is less than 10, that implies a is less than 10 by 16. That implies a is less than 1. But what we require, a is a positive integer, a is an integer, positive integer. Hence, a is a positive integer we want. Hence, this value is not acceptable. B and C we have any integer, a is a positive integer. Let's have this restriction also. So that ultimately we will have around 19 values for ABC if a plus b plus c is less than 10. What ultimately we could get is that a plus b plus c for the conditions is equal to a into p minus 1 into q minus 1. This is the equation 1, where we have got that a plus b plus c is less than 10. Even though it is not there in the question, I am just putting this value so that you will understand. A is not equal to b is not equal to c, and a being positive integer, these are the conditions. We will get different values of a plus b plus c, and p and q are prime numbers. This is equation 2. Under these conditions, we get a set of a plus b plus c values, and if there are no restrictions, there are infinite solutions. No restrictions or no constraints imply many solutions. If there are conditions like this, that a plus b plus c is less than 10 and a being the positive integer, then we have limited number of solutions. On the basis of the question given in the examination, you try to find the solution and you try to find the number of solutions. This is a mix of set theory. You have to understand what is the meaning of the equation given. Set P is equal to x is such that ax square plus bx plus c is equal to 0 and x is a prime number. And we have to solve a plus b plus c is equal to how much. If any other conditions are given, then we will solve the set of the triplets. If the conditions are not given, there are infinite solutions. If the conditions are given like a plus b plus c is less than 0, less than 10, we have different kinds of a and b and c. Here, if a is equal to 1, let us say a typical solution, b is equal to what we have got previously. If A is equal to 1, B is equal to minus 4 and C is equal to plus 4, that equation becomes x square minus 4x plus 4 is equal to 0. That implies the roots as x is equal to 2 and 2. That means P is equal to 2 and 2. P is equal to 2 and Q is equal to 2. Because this is x minus 2 into x minus 2 is equal to 0. That is in the form of x minus p into x minus q is equal to 0. That implies p is equal to 2 and q is equal to 2, and a plus b plus c is equal to 2. You try for other values, put your own restrictions like what I have put. Try to use this method and concepts and put your constraints and solve this problem for various constraints, so that you will get the experience of solving this problem. And best of luck to everybody. With this, I want to conclude this lecture with condition that if P is equal to x such that set P is equal to x such that ax square plus bx plus c is equal to 0 and x is equal to a prime number, then a plus b plus c is equal to a into p minus 1 into q minus 1, where p and q are roots of given equation ax square plus bx plus c is equal to 0 and are prime. This is the condition that is to be met for a plus b plus c. A plus b plus c is equal to a into p minus 1 into q minus 1. From this we will derive the values of ABC, a plus b plus c. Once we have further restrictions on A and B and C. Thank you for listening to me. Best of luck to everybody. And if you feel there is a value addition to you because of this lecture, kindly hype this lecture, kindly share this lecture, and subscribe to my channel Maths and Science by IITian. Never restrict yourselves when you are studying a particular chapter. Never restrict yourself that you will be asked only questions pertaining to set theory when you are studying sets. Sets can be combined with Diophantine equations, sets can be combined with quadratic equations, and a Diophantine equation can be combined with a polynomial Diophantine equation. A polynomial Diophantine equation can be combined with considered for quadratic Diophantine equation. That means we have to see mathematics on a holistic view and set theory on a holistic view. It's a typical example in set theory combined with quadratic equations and Diophantine equations. Thank you for listening to me. Best of luck to everybody. Thank you for viewing my lecture. Please hype, share and subscribe to my channel Maths and Science by IITian. I will be bringing this type of problems in set theory for some more lectures, and let us see. We will move to the level of understanding the set theory questions